All right, June 2017 final exam. Let's see, what we'll do is I'll graph these, I'll pause it, graph these, and then I'll come back. Let's see, transformations. This is a 4-point question. So let's make sure that, we're kind of given enough to justify 4 points. That's probably where it's coming from right there. Use rigid motion transformations to explain why those figures are congruent. So I'll pause it and be back in a few. Okay, we're back. Now this is the graph of these coordinates. And so the graph piece is getting the dots. Label is putting the letters near it. Okay. Determine and state the single transformation where triangle DEF is the image of triangle ABC. Looks like it's going to be this vertical line here. This is x equals -1. All right, that's the perpendicular bisector of AD and CF. Okay, so it's going to map those onto each other. And it's going to be the orientation, everything kind of suggests it was a line reflection. So state the single transformation. We can do this in explanation or in algebraic notation, or there's a lot of ways. So I'm just going to explain it. So we're going to reflect triangle ABC over the line, x equals -1 to map. Oops, I'm going backwards on that. Yeah, DEF is the image. To get the image, triangle DEF. So DEF is the image of ABC after this move. Okay, so use the transformation to explain why. So they don't want you to use coordinate geometry. They don't want you to do the side-side-side way. They essentially want you to refer to rigid motion transformations. So here's what we'll do. Triangle ABC is congruent to triangle DEF because there is a sequence of rigid motion transformations in this case line reflection that maps triangle ABC onto triangle DEF. And that's it. Seems a little light for a 4-pointer, but that's really all that's required. Okay, another proof. So what we do with this is the pre-proofing to this is really key. And what you want to do is kind of see how many of the moves we can make on our own. And what I mean by that is we can take a given and make a move with it. So if RS and TV bisect each other at point X, that means TV gets cut into 2 equal halves, and so does RS. Now the reason I'm using a single there and a double there is because RX might be different than TX. Okay, it looks like it. Don't assume this is a right angle, even though it looks it. All right, we can't fall for that. Okay. Vertical angles is a conclusion you're going to make on your own. So every move you make is going to probably gain you a point. It's a 4-point question. Okay. So let's see how this works. First, I have to state the given. So there it is. You have to state it. You can't just make the move without stating it in your proof. Okay. Sorry, back up. The markings, and I didn't quite finish the pre-proof. The markings is part of the pre-proof, and I might not have said this. It's going to be a side angle side triangle congruence theorem proof. So, all right. Now, let's go through this. Let's get back into the proof. So here's the given. Now, the first point you earn is when you make a move that's valid off of that given. So what I would say is Tx is congruent to Vx, and Rx is congruent to Sx because of... Now, there's a lot of ways you can explain this. There is a definition that we can use. I'm going to say definition of segment bisector. You could explain it. When segments bisect each other, they cut each other into two congruent halves. All right. So however you want to do that. Now that's going to get us both S's. Okay. There's one pair of sides congruent, so that's one S, and then there's the second. Now the angle is going to come from this. Okay. This is a conclusion you make just from the diagram. So I would say angle TXR is congruent to angle VXS. And this is because vertical angles are congruent. Now, be careful on this. You cannot just say angle X is congruent to angle X because we don't know which X we're talking about. If you don't want to write the three-letter path, you could label them angles 1 and 2. Okay, that's probably the safer bet. So make sure that you are, being certain that that's the angle you want to be talking about. All right, this gives us our pair of angles congruent. So we did satisfy side angle side. What we can say now is triangle. TRX is congruent to triangle. I got to get this right. Got to coordinate it. So VSX by side angle side, triangle congruence theorem. There's two more steps, at least. So here's what I'm seeing now. Step 5, I would take the congruent triangles and get a pair of corresponding angles congruent. All right, now, angle T and angle V are now congruent, and I only need to use those as one letter because there's no other angle we could be talking about. So angle T is congruent to angle V. And I'll write this out, but you might be able to get away with CPCTC here. I'm going to write it out, though, because corresponding, the key word to this is corresponding. When I see corresponding written, now I'm convinced that the student knows what they're talking about here. So corresponding parts of congruent triangles are congruent. Now, I've seen this happen a lot. Don't talk about congruent triangles until a previous step has congruent triangles. Okay? And then 6, now we can say TR is parallel to SV because when alternate interior angles are congruent, lines cut by a transversal are parallel. Might be able to get away with by alternate interior angles theorem, but it's a little bit, depends on if the teacher accepts that or not. So there it is, 4 points. All right, so for number 34, let's see. We have a cylinder shape. Now it's laying on its side, okay? But we're going to use the same formula as if it were standing up, okay? So let's see. Gallons is volume, like the 34.5 feet. There's probably going to be some conversion, yeah. So it looks like it right there. Conversion is going to be necessary. Some rounding. They don't say round anymore. The indicator that you're supposed to round is when they say nearest tenth or something like that. Okay, if they say leave it in terms of pi, we're not rounding. So just kind of making sure we know what the test is looking for, depending on what they say. All right, so let's see if we can tackle this problem. So, okay, the tank holds a maximum of 20,000 gallons of gasoline, and let's see. All right, so first thing I did here was converted 20,000 gallons of gas over to cubic feet, okay? And I used this conversion. The reason is really what I'm looking for is the diameter, and then I'm going to add 1. To get the diameter, I need the radius, and then we're going to add this 1 at the end, 1 foot. So I'm going to need 2 radii so that I can get the diameter. So we're going to think, okay, get the diameter plus 1 is the big idea here. All right, so for the volume formula, it's going to be pi r squared h, but I'm going to have to come back to that because I don't have a volume yet. I've got gallons, but I don't have conversion over to feet cubed. Now, this is what I do, and I know there's a lot of different methods, but here's what I say. I have currently 20,000 gallons. I want to convert that to some number of cubic feet, but I don't know what it is. Now I do have a direct conversion, so if I put feet cubed on the bottom, I should also put feet cubed on the bottom of this and gallons on top. Okay, now I'm going to ignore units of measure, but science would never do that. So I'm going to just say 7.48x equals 20,000, because 20,000 times 1. Divide by 7.48, and what we've come up with is the cubic feet that we needed. Yeah. So let's type that in. 2,673.796. Now, one of the things we're supposed to teach is that you don't round to the end. So leave this in your calculator and use it for future steps. Now we'll come back over to our formula. And this is actually our volume. This is feet cubed, right? What we solve for is feet cubed. So that's our volume in feet cubed. 2,673 equals pi times, we don't know what the radius is, so let's just leave it as r squared. We do know the height they gave us. It's up top, is 34.5 feet. Okay, so what I did in my calculator is I divided by 34.5, and then I divided by pi. Be really careful of this. If you do it all at once, make sure you have the big fraction thing on your calculator, or you put the bottom in parentheses. It's up to you. But let's just be really careful about that. So if you're doing it right with your calculator, you'll get r squared is 24.669. If you don't get that, if you get something that's a lot bigger, it's probably because you didn't handle this division by 34.5 pi right. Okay. All right, so now we have to square root both sides, get rid of the squared. And I get 4.9668. It's just r. But remember, we want the diameter plus 1. So diameter is 2 of those, 4.9668, which is, let's see, 9.93. Now we have to add 1 to get a foot out, I guess. So that's going to be 10.9 is the nearest tenth of a foot. All right, that's it for the part 3s, which are 4 points each. So consider how much more work there is on those, and make sure that you're showing enough to justify 4 points. Thanks so much.